Okay, today we're talking about Chapter 5, Section 5, Solving Rational Equations. Alright, so just reading off the page. No, let's snip everything actually. I think snipping is good here. Alrighty, so thus far we have studied two types of equations in one variable. We have studied linear equations and quadratic equations. In this section we will study another type of equation called a rational equation. Right? So rational equations are, well, we talked about them. But now we're going to solve them. An equation with one or more rational expressions is called a rational equation. All right, one moment. All right, so that makes sense, right? An equation with one or more rational expressions is called a rational equation. So we have, these are three. We have three rational expressions, therefore we have three rational equations. Um, Same thing here, right? So to understand the process of solving a rational equation, first review the procedure of clearing fractions. Right, so we did this last week, clearing fractions, and we're going to do that again here. Right, we clear fractions because, well, it's so much easier solving any sort of equation as if they're not in fractions, all right? And this is definitely something that you've done in your math courses for a long time. You cleared fractions, right? So we're going to look at this particular problem, and I'm pretty sure the book, what it does is it does both sides. All right, yeah, okay, so I'm going to bring your attention to the textbook here. So we're looking at the least common denominator of the left side and the right side. So 2, 3, and 4. What's the smallest number 2, 3, and 4 will go into? Well, it's 12. So what the textbook does, and there's nothing wrong with this, it's just I like to get straight to the point and solve the problem as swiftly as possible and as correct as possible. Okay. So what I would have to do here is I need to multiply my equation by 12. So instead of multiplying the right side and the left side by 12, I want to multiply the entire problem by 12. And I'll show you what I mean here in a second. So I would say 1/2 x plus 1/3 is equal to 1/4 x. Okay, so what I would say is, okay, so, kind of the same conversation I just had, right? So 2, 3, and 4, what's the smallest number all three of those are going to? And that's 12. The textbook, again, just to reiterate, multiply 12 by both sides. What I'm going to do, okay, is I'm going to just multiply this entire problem by 12. Okay, and we're going to have the same solution here, okay? So let's just start here. So if I did 12 times 1/2 x, well, 12 times 1 is 12. 12 divided by 2 is 6. So we would say 6x. 12 times 1/3, well, 12 times 1 is still 12. 12 divided by 3 is 4, so plus 4. Then 12 times 1/4, 12 over 4 is 3. Okay, and again, so similarly to how I keep this addition sign there, I'm going to put an equal sign right here. Okay, so is equal to 3x. Okay, and that's it. From here, we know how to solve this problem, but that's all we did. We just cleared the fractions, we uh, distributed through, and then we can solve. And again, this is definitely a problem that's super duper easy to solve. So I'm just gonna move on with this section. I guess they're all gonna be super duper easy to solve, huh? It's looking like it. Alrighty. So again, same procedure. Just gonna 3/5 plus 1 over x is equal to 2/3. Right, again, I'm looking at my denominators, 5, x, and 3. Well, the smallest number that all three of those will go into is 15x. Okay. And then we distribute, so 15x times 3 over 5. Well, well, there's a couple ways you can do this. You could say 15 times 3, which is 45, divided by 5 is 9. Or you could say, just kind of write this out, or there are many ways that people like to do their computation on their own, either in their head or on paper. But you could say something like, okay, so this 5 and this 15 turns to a 3, and then 3 times 3 is 9. Okay, so there are multiple ways to go about this, but again, in the end, it's just simply distributing, like so. So we say 9x and then 15x, I'm sorry, yeah, 15x times 1 over x. Well, that's just going to be plus, the 15's cancel, so it's going to be plus 15. And then 15x times 2/3, that's just going to be 10x. Okay. And then we subtract 9x from both sides, and we'll have 15 is equal to x. All right, now we get to some fun stuff. And by fun, I mean, ugh. But these are things that you just have to do. If you are curious, you're more than welcome to follow along. Just kind of see what we use this for. You can look at the other playlists I have going on. One of them is an applied calculus course, and we do this stuff in that course as well. But again, by the time we get to there, we can just kind of do this with in our sleep. But and of course I know that many of you, especially if you're going into a STEM field, will eventually get there because I was also that student. I was also like, this is dumb. I can't believe I'm doing this. What I need is this to do a college degree or to get a college degree for. But the funny thing is, those people actually know what they're talking about when they make you do all this stuff. It's the weirdest thing. Alrighty. Looking here, what is my least common denominator? Okay, well again, I only have one denominator, and it's just w plus 1. So I'll multiply this entire problem by w plus 1. Okay. I distribute through here, so I'm just going to say 3 times w plus 1 minus 6w, because the w plus 1s will cancel, is equal to 6, because again the 6w's, the w plus 1s will cancel. Okay, so let's distribute this 3 through. So we're going to have 3w plus 3 minus 6w is equal to 6. Right. And then we're going to combine like terms. It looks like we'll have a negative 3w is equal to a 3. So it looks like we'll have, and I guess you can't really see my toolbar down here, but there's a big old toolbar in the way. But I can probably write there and pretend like it's not there for you. W is equal to a negative 1. Okay. Now, up to this point, I have not been checking my solutions. Okay. So let's go ahead and let's pick this random one to test. All right. And obviously, it's not completely random because I did it for a reason. So if my solution here is w is equal to negative 1. Okay. So that means if I plugged a negative 1 in for w, this equation would be balanced out. Okay. Well, let's plug it negative 1 in for w. Okay, well we plug in negative 1 in, and this is larger, so let's plug it into here. If we plugged in negative 1 right here, and if we plugged in negative 1 right here, all right, well negative 1 plus 1 is 0. All right, what is probably the only rule you'll ever remember in mathematics, and that is you cannot divide by 0. Okay, so we can't divide by 0, but that is my solution. Okay, so what that tells me is that, okay, so that must be what we call an extraneous solution, right? And the extraneous solution is a solution that works algebraically, algebraically being all this stuff we did here, that works algebraically, right? But it does not work logically, meaning, again, when we plugged the negative 1 in for our w, we got a 0 for the denominator. Okay, so this is an extraneous solution or a restricted value. Restricted value sounds exactly what it sounds, or it is exactly what it sounds like. it is a value that is restricted. We cannot use it. Okay, so my solution here is actually just going to be the empty set because there is no solution to this particular problem. Okay, so how can we avoid this problem in the future? Well, let's go back. Actually, well, let me see what example 4 has in store for us before I tackle that. Okay. Okay. So um, the way you can avoid this problem in the future is before you do any sort of algebraic manipulation. The algebraic manipulation being, what we did here. We multiply by 12 and stuff. Before we do any sort of algebraic manipulation, we're going to look at the variables, and we're going to say, okay, so what can these variables not be? Okay. Well, in the first example, it was pretty easy. I mean, the variables were essentially in the numerator, right? They're not explicitly in the denominator. So my variables could be anything. It does not matter. It could be 0. It could be -1. It could be negative trillion. It's okay. It doesn't matter because we'll still get a solution. Okay. Does not matter what my variables are. In this particular case, it did matter. Okay. X could not be 0. Right? So what we should have done, and didn't do it on purpose, but what we should have done here is before we begin, we say, okay, so x cannot be equal to 0, and then proceed with my algebra. And on this particular problem, we would say w cannot equal to -1, and then proceed. Okay, so that's what we're going to start doing with our problems. We're going to start getting rid of start talking about our restricted value. Okay, so let's start off here. So we've got 1 plus 3 over x is equal to 28 over x squared. So first thing we're going to do is we're going to say, okay, so looking at my denominator, what can my x not equal to? Well, there's only one value that the x cannot be equal to here, and that is 0. So we're going to immediately write right here, x cannot be equal to 0. Okay, so if we do the algebra here and we get 0 for a solution, then we're going to know we did it wrong. Well, not wrong. I'm sorry. We didn't do it wrong. We're going to know that there's going to be no solution. Sorry. It's not that we're going to do it wrong. Okay. Again, we did everything on this page right. It was just wrong, which is actually kind of poetic and philosophical for life. You can do everything right, and you can still be wrong. I think that's pretty poetic. But anyways, so let's begin this process. 1 over, it's not 1 over anything. It's just simply 1. Okay, so what do I need to multiply this entire problem by? Well, it looks like just simply an x squared. X squared is my least common denominator. So if I distribute through here, I've got x squared. If I distribute through here, one of the x's cancel, so we end up with just simply 3x. If I distribute through here, the x squareds cancel, and I end up with 28. Okay, so right away it looks like we're going to be having us a quadratic equation. So let's go ahead and move the 28 to the left side. So we're going to end up with an x squared plus 3x minus 28 is equal to 0. Okay, let's fix that 0 up a little bit. All right, we're going to factor now. So what does this factor into? It looks like a 7 and a 4. So it looks like x plus 7 and x minus 4 is equal to 0. So this means that x is equal to either a -7 or x is equal to a +4. Okay, and does either of those are either of those 0? No. Well, then we're good. This problem's over, right? Then the solution set is just simply going to be -7, 4. Okay. Okay, so remember those times I said, okay, so these are these equations you need to memorize because you're going to be doing them quite often. This is an example of one of those equations, all right? What we're going to have to do is immediately spot that we do have a difference of squares and then solve from there. Okay, so let's look at this. We're going to go ahead and factor this, the denominator there, before we write down our restricted values. Okay, and you'll see why here in a moment. So let's go ahead and we're going to put this over here because let's put it right here. I'm going to need some room on this one. Actually, let's not write p squared minus 9 real fast. Okay, so p squared minus 9, okay, again, so p squared minus 9 is a difference of squares, and difference of squares factor into a p plus 3 and p minus, p minus 3. Okay. Right, so looking at my denominator here, what is my least common denominator? Well, actually, I'm sorry, before we get to that, notice how if I put in a negative 3 right here, or a negative 3 right here, I get 0. And if I plug in a positive 3 right here, I also get 0, right? Negative 3 plus 3 is 0, and then a positive 3 minus 3 is also 0. Let me fix this 3. All right. So my restricted values are that p cannot be equal to a negative 3 or a positive 3. Okay. So now we can proceed with our algebra. And again, algebra just simply doing the manipulation here. Okay. So when I distribute the first one, that's pretty easy. The entire denominator is going to cancel, so we're just going to have a 36, and that's going to be equal to, well, the p plus 3s are going to cancel whenever I distribute here, so what's going to remain is p minus 3, so we're going to have a 2p times p minus 3, and then we're going to distribute all the way here, and, well, unfortunately, it's going to keep everything. So that's going to be minus, let's put this in parentheses, p plus 3, actually, brackets, p plus 3, p minus 3. Okay, so we've got some work ahead of us. All right, so let's go ahead and get rid of uh, the parentheses. Let's fix up this one real quick. Oh, wrong eraser. Here we go. So we've got 36 is equal to 2p squared, and this will be minus 6p. Right? And then let's deal with this on the other side here. Well, p plus 3, p minus 3. Well, we know that obviously because we just did the opposite of it, right? We took p squared minus 9 and turn it into p plus 3, p minus 3. So we know what p plus 3, p. I'm done. I'm going to stop saying it. Sometimes I get a little tongue-tied. Maybe I had too much coffee or too little. P squared minus 9. Okay, and this is going to be one we continue on the next page. Okay, so we've got 36. 30 is equal to 2p squared. All right, so we're going to do, oh, did I miss a sign there? I did. Shoot. Okay. That's supposed to be a minus p squared minus 9. So let's fix that over here. Right. Let's proceed again. Okay, but 36 is equal to 2p squared minus 6p. And then again, this minus sign here in front of the p squared minus 9, that's just basically saying a negative 1. Right? It's a negative 1 getting distributed through. Okay, so it's going to be negative 1 times p squared. So it's going to be minus p squared. And then negative 1 times negative 9 is going to be plus 9. Okay. Right. Now let's combine all like terms. And it looks like we're going to just put the 0 on the left, right? And I'm like you. I also like having my zeros on the right usually, but in this particular case, we're just going to put all the zeros on the I'm sorry, my 0 on the left because it just works out better that way. So we're going to subtract 36 on both sides. So we're going to have a 0. 0 is equal to a 2p squared. I'm sorry, I messed up there. We got to combine like terms. So 2p squared minus p squared is just going to be simply a p squared. Okay. We have a minus 6p. That's just all by itself. So let's underline that. Just kind of differentiate it. So minus 6p. And then we're going to take 9 and subtract 36. So we're going to have a negative or minus 27. Okay. Now we factor p squared minus 6p minus 27, and that looks like it factors into a 9 and a 3, so we're going to have a p, looks like a minus 9, and a p plus 3. Let's put this on the next page. So I've got p is going to be equal to a positive 9, and p is going to be equal to a negative 3. Now, we talked about this problem a while ago. It's been a pretty long problem, but if you recall, we said that p cannot be equal to a negative 3. Okay, that is an extraneous solution, an extraneous value, a restricted value. Okay, so what that means is that p is equal to negative 3 is not a solution. My only solution here is p is equal to 9, right? And of course, if I put that as my solution set, I just simply put 9 like so. Okay, so solving a literal equation involving rational expressions. So there are new numbers here. Looks like we have velocity, mass, and I don't know, lots of stuff. We don't really know what those variables mean right now. Okay. So this just simply says solve the indicated variable. Solve for the indicated variable. V is equal to, big V is equal to little m times little v all over little m plus big M. Okay, we're trying to solve for m. So how do we solve for m? This is actually a pretty good problem because if we're trying to solve for little m, we notice right off the bat that that both my m's are on the same side. You're gonna have a lot of these problems from here until you get your degree, and the very first step you need to do is basically what this entire section has been about. We need to clear our fractions, right? So what we're going to do right away is multiply both sides by little m plus big M. So let's go ahead and write that out. Let's try this again. So V is equal to that. Okay. So we're going to go ahead and multiply this entire problem by m plus m. Let's fix that up also. Okay. Well, when we distribute, all right, well, this becomes pretty easy. It becomes a big V times m plus m, like so. And then we distribute here, well, we cancel with the denominator, so we're just going to be equal to mv. Okay. And then we're going to distribute this big V here. So we have V m little m plus V big M is equal to mv. Now again, we're trying to solve this for little m. Okay, so if we're trying to solve for little m, then it makes sense that we need to get the little m by itself, right? Well, okay. So in order to do this, I need to get the little m by itself. So here's what we're going to do. We are going to let's go ahead and subtract. Let's subtract Vm, big V, little m, from both sides because I want to get both of the little m's on one side. Okay, so if I want to get both of the little m's on one side, let's go put this on the next page, I guess. I'm going to end up with a v, oh, v big M. I could have chose a little bit better of letters. mv minus vm. Okay, and now what I need to do is, going back to what we've done before, we need to factor out the little m. So we're going to end up with a capital V, big M, that's equal to a, we're factoring out the little m, so what remains is v minus v, like so. And then we're going to divide both sides by v minus v, so we're going to end up with a vm over v minus big V is equal to m. And I believe that is all they're wanting. Hmm. Yeah, I think so. So that is the problem there. Let me make sure that's all they're wanting. Yeah, that's it. Okay. Well, that concludes the lecture.